Mindsetters, welcome to Learn Extra Live. Today we're doing grade 10 physical science and we're with Tracy. Tracy, how are you today?
Hello, Katlego. Good, and you? First show with you. It's
Good,
great.
it is the first show. Yeah, I'm very excited. And it's been a while since I've been here, so I am amped for this show.
Am I going to have to remind you what to do?
Yeah, no, just whisper in my ear.
Okay, brilliant.
Tell us more about your chemistry revision that you're doing today.
Well, grade 10s today, make sure you draw near because we are doing all the chemistry revisions. So we're doing matter and materials, you would have done that in the first term, and physical and chemical change up to types of reactions, you would have done this term. And now before we carry on, okay, this is for two very special grade 10s who have begged me for weeks and very nicely begged me today at school. Hello, Matthew. Hello, Nathan.
There you go.
You've had your shout out now.
Yeah.
Okay, so
hi, guys.
Stop begging. Okay. Brilliant.
Don't fall asleep.
Yeah, no.
Then, you know.
Well, I know Matthew's mother. I'll slap her.
Okay, cool. Awesome.
Yes. There we go.
Awesome. Thank you, Tracy.
Okay.
So
I'm going to go get ready.
Okay, sure. You can.
Okay.
So guys, you know how to get hold of us. Our Facebook page, facebook.com/LearnExtra. And our Twitter handle is @LearnExtra. I hope you guys are ready for an exciting show. And thank you to Liberty for bringing us this exciting show. And also, other exciting news, we have the Casio card here to give away to the best mindsetter today, as well as the labeler. So make sure that you are in tuned and in checked and on the ball for today's show because it is going to be exciting. And you guys know about Tracy. You know she talks and talks, but we're ready for her today because today's Tuesday and we are amped. And also, I'd love to know about your exams and how you're finding them and if they're difficult, easy, and where you need help, and perhaps where we can help you today for physical science. So let us know.
Absolutely.
Over to you, Tracy.
Excellent. Thank you. I said that so wrong.
Yeah, but it's okay.
Yeah, name's not my strong suit, eh? Anyway, okay, so grade 10s, back to the important thing. Now, what I really hope you have near you is a periodic table, guys. You really, really need to have one. I'm hoping whatever textbook you're using has one, or at least you've got one from your teacher somewhere along the line, because you do need to have a periodic table in order to do chemistry. And remember, for any physical science exam, you will be given a periodic table. It's not something you're expected to know off your head, which is a good thing. So, like I said earlier, we're going to look at matter and materials. Now, what you would have covered in matter materials are things like the properties of materials. You would have done classification, definitions of things like viscosity, temperature, boiling points, melting points, magnetism, conductivity of electricity or heat, that sort of stuff. You would have also looked at the trends on the periodic table, looking at ionization energies, electron affinity, electron negativity, how they all work on the periodic table, how atomic radius works, ionic radius, all of that sort of stuff. You also then would have in matter and materials done that wonderful prac where you had to do the boiling and melting point of water, and you would have done the heating curve. So you would have to draw that funny little graph where you explained all the energy changes in it. Guys, that's a very important graph, okay? They've made a big emphasis out of that in all the meetings I've gone to about the new curriculum. They really have made quite a thing over that graph, so make sure you know it. Then you would have gone on to chemical change. Now, inside chemical change, it would have been introduced using physical and chemical change. We are going to look at those a little bit later on again. And then basically you did two types of reactions, synthesis and decomposition, and balancing of chemical equations. Make sure that in both of these sections you would have done it twice. You can write chemical formulae. That's very, very important. Okay, so there is a whole bunch of what we call polyatomic ions, which you really do need to know. Okay, and how to work out your valencies on the periodic table. All of that sort of stuff is really important. Now, this section, we could do theory coming out of ears, but I've chosen 7 questions, and I'm hoping we're going to cover quite a lot of all the theory. Obviously, we can't cover everything, but like we've said earlier, please send in your questions. We obviously need to know where you're struggling. We're going to look at making formula a little bit later on, balancing some equations, and I have a doozy of a question to balance a little bit later on. It's going to be fun when we get there. Anyway, so let's start with matter and materials, and the best thing is I have what we call a concept map. Okay, some of you might know it as a mind map, some of you might know it as a flowchart. Really, it's just a concept map where we're now going to break matter and materials up into the two sections that it really is, and how we classify this is broad classification of materials, okay? So the first thing is we go, well, if we have pure substances, then we have, well, it's not an impure substance because that's just a silly name for it. We don't call it that. But we can also have mixtures, okay? So, ooh, wow, me and the pen. So we have mixtures, okay? But if we go down to pure substances, we can classify these as two types of pure substances, okay? Because not everything falls into a pure substance. You've got to get this. Now, hopefully, seeing the fact that we've gone a pure substance and we've gone mixtures, you're now going, well, if it's not a mixture, then it can fit into two different categories. Either we're going to be talking about elements, or we're going to be talking about compounds. Okay? Mixtures are not pure substances because mixtures do not have a fixed ratio. So if you think of a salt water solution, okay, that is a mixture. The salt dissolves in the water, but it can dissolve as much as we like or as little as we like. Okay, so there's no fixed ratio. But if I look at the compound salt, NaCl, sodium and chlorine will only bond with one sodium to one chlorine. That's what makes it a compound. It's also what makes it a pure substance. It has a fixed ratio. Okay, so a pure substance can only consist of particles of one kind. Okay, I'm not saying atoms of one kind because then that makes it an element. Compounds can consist of two or more elements that are either ionically or covalently bonded together. Generally, though, we will call compounds they're covalently bonded, but we decided to call those molecules instead. So, now, mixtures fall into two categories, and these now get great names, okay? The first one is a homogeneous mixture, okay? And I've written it down because it's one of those words which I struggle to spell, okay? It's a homogeneous mixture. That means that it's all of the same phase. So the air we breathe, our atmosphere, this is a homogeneous mixture, generally, okay, because it's all gas particles. When there's water in the air, then it's not quite as homogeneous, but it's still a little bit of water vapor, so it's homogeneous, all of the same. Or if we have a mixture, say, of salt and sulfur, not a good mixture, but we'll put it there, salt and sulfur, they in powder form, they're both in solid form, they're in powder form, so they're the same phase, okay? Then we get heterogeneous, okay? Heterogeneous mixtures. Now, these are mixtures that aren't in the same phase, okay? And boy, some of you have seen these when you're sick and your mother gives you an emulsion, okay? Generally, these are the horrible taste. It's generally a cough mixture, and when you, yep, that's spelled right. When you look at it, it looks like there's like a grainy powder in it, okay? And it's an emulsion. You actually have to, and they're generally a cloudy color. They're not clear. They're cloudy. In medicine, they generally taste horrible, but you got to that age where they think you're old enough not to have nice taste in medicine. Okay, I wish they didn't do that. But anyway, so emulsions are cloudy mixtures, okay? And it's heterogeneous because there's a solid in it. The other one is a suspension. Now, a suspension generally can also be with solids in, but generally these are liquids. So, salad dressing is a suspension because there you'll have the vinegar and the oil that you have together. If you leave it, they will separate, and you actually have to shake them together to mix them again before you use it, okay? And that becomes a suspension because you have one that's suspended in the other. Okay, now, in all of these, this is where we can now take into where you would have to learn the different properties of materials and what they mean and their definitions, which is what my next question's about. Okay, now, I chose this question very deliberately, grade 10s. Part of what you're learning is not just the concepts and the knowledge, but it's also how to write questions and to answer questions. Now, it says, consider the following list of elements. So we got bromine, carbon, cobalt, copper, fluorine, iodine, magnesium, mercury, neon, silicon, sulfur. Okay, and I'm hoping some of you have written it down. Then it says, write the chemical formula. That is such an important part of the instruction, of the element that fits each description best. Guys, please be careful here. And as a matric marker, I see this all the time. If we tell you to write the chemical formula and you write the name, you get marked wrong. Okay? And I was thinking on the way here, how best to get you to understand why it would be marked wrong. It's like when you had to apply for your ID documents. Some of you have already. Where it says date of birth, if you had written the date you applied for your ID document, they're going to throw the form back at you, because that makes you 0 in age, in months, days, hours, whatever, and you filled it in incorrectly because you didn't follow the instruction. Okay, so that's really important here. You've got to follow the instruction. It says write the chemical formula. So what I need us to do before we even look at the question is go, okay, do we know the chemical formulae? Because that's important. So let's quickly go through this. And bromine, capital B, little r, not what that was, little r. Carbon is a C. Cobalt, C, lowercase o. Guys, it's got to be a lowercase, because if you write C with a capital O next to it or an O that looks like a capital O, you've written carbon monoxide, completely different element altogether. In fact, it's a compound now, not an element. Copper is Cu. Fluorine is F. I might not have left myself enough space here. F. Iodine is I. Magnesium is Mg. So far, nothing difficult. Mercury, which is an important one, is Hg. Neon is Ne. Silicon is Si. And guys, please, I'm begging so nicely. Silicon is one of those elements where spelling absolutely counts. Okay? Because if I put an E at the end of this word, it becomes silicone. Okay? And silicone is what they use in plastic surgery. And as some of my kids were telling me, it's also used in sealing baths and stuff like that. Very different to silicon. Okay, so do not put an E at the end of that name. And then sulfur is an S. You must be able to do this. This is not an option in grade 10s. Okay, so let's go here to the list. The first thing is, which element is ferromagnetic? So I'm asking you, which of these is magnetic? And there's only one. In fact, you can only use every element once. And I'm hoping some of you are shouting at me going, it's cobalt. Absolutely. Remember the only 3 ferromagnetic materials on the periodic table? Nickel, iron, and cobalt. Okay, so I've used cobalt. Let's scratch it off. I don't need it. Then they say they want something that's non-magnetic. Well, pretty much everything else on the list is non-magnetic, okay? So let's leave that one, because I have copper that's non-magnetic. In fact, everything's non-magnetic. Let's leave that one for now, because we can only use everything once. Next question, diatomic liquid. Okay, so we go, first of all, there's only 2 liquids in this list, mercury, bromine, okay, something you should know from your periodic table. Mercury is a metal, it's going to be Hg. Bromine is one of your halogens. So bromine sits on group 7. Bromine will be diatomic. We write it as Br2. So my diatomic liquid is Br. Now, some of you are going, why are you not writing it as Br2? Because the element is bromine. Okay, I'm not using it. We're going to leave it at that. Then they say to me, it's a material that's brittle and cannot conduct electricity and heat. Okay, well, first of all, let's get rid of the bromine, because now I've done that one. Okay, so it's brittle, cannot conduct electricity and heat. Well, carbon can conduct electricity, it's not that one. Copper can conduct electricity, it's not that one. Fluorine's a gas, it's not that. Iodine's a non-metal, can't conduct electricity. Don't worry about it. And it can, but it's it's not brittle, okay? I'm hoping you guys have seen iodine. It actually supplements. Remember, it goes from solid to gas without going through the phase. Magnesium can conduct, mercury can conduct, neon is a gas, definitely not brittle. Silicon can, sort of conduct. It's one of our semi-metals, which means it's sulfur. Sulfur's a better choice, actually. So we're going to put sulfur there. So that would be sulfur, and I can now cross it off my list, okay? Next one. It's a monatomic gas. And you know what? There's actually only one other gas. Well, there's two gases on my table, fluorine and neon. And we go, well, fluorine's the same as bromine. It's diatomic because it's a halogen, which means that has to be neon. Off we go. So that's neon. Brilliant. A black solid, nice giveaway, that can conduct electricity, but is neither malleable nor ductile. In other words, it can conduct electricity, but it doesn't have the usual traits of a metal, which are malleability and ductility. So we go, oh, hang on, mate, we know what that is. Carbon, okay, graphite. So that's carbon. All right, so that's C. There we go. Next one, a hard element. Okay, I don't want to keep going up and down. A hard element that is brittle in crystalline form, has a good metallic luster, okay, expands as it freezes, like water does, and conducts electricity. Wow, this one's lots, okay? It's hard, but it's brittle in crystalline structure. It's a good conductor, but it expands. Metals shouldn't expand when they freeze. They should contract, okay? So this is one where we're going, and again, it's got a lot of metallic properties, but then it's got a property of a non-metal. So the only thing that fits in there is silicon. So let's put silicon in. Okay, there we go. I'm not going to go up to the list again. I'm hoping you guys have got it. Then a shiny, brittle solid, which is a thermal insulator and is non-magnetic. Oh, brilliant. Okay, so out of our list, we go, it's got to be shiny. It's got to be a metal then. But this is a thermal insulator, so it can't be a metal. All right, because that would mean that it's a thermal conductor, and it's non-magnetic, so, but it's brittle. The only thing that's left here is iodine. Okay, only thing that's left is iodine for that. Then, a liquid, also known as quicksilver, this is the best giveaway here, it's known as quicksilver, and is used in thermometers and barometers. Hopefully you guys are going, I know. It's mercury, absolutely. Hg, and then we have a diatomic gas. Now, watch here. I want to show you what we've ended up doing here. We've taken out the iodine. Okay, we've used mercury. Okay, and we haven't used the copper just yet. But now they want the diatomic gas. Sorry, so that's fluorine. So let's put the fluorine in, which means we can go back to my one that I put here, which says it's non-magnetic. Now, grade 10s, there's two options. I have copper left and I have magnesium left. Both of those are acceptable answers. Okay? They would both have to be marked right because they're both non-magnetic. Okay? If I wanted something a little more specific, so say I really wanted copper, then I would probably say a brown substance that's non-magnetic, okay? Or if I wanted magnesium, I would probably say a substance with a typical metallic luster that's non-magnetic. Copper doesn't fit into that because it is that beautiful brown color. Magnesium is your typical metal, it's gray silver. Okay, so what this means, and grade 10s, don't rush questions like this. Often you're going to get these, and this is actually the best way to test a lot of stuff. Because what I've actually done in this question is I've tested whether you understand what is magnetic, non-magnetic. I've tested whether you understand the properties of metals and non-metals. I've tested whether you understand which gases are diatomic and which aren't. So I've tested the whole halogens issue, okay? There's a lot of stuff that we've tested in this question. And it looks quite simple, and it would be worth 10 marks in an exam, but don't rush it. Spend the time working through them, okay? And I think, that brings us to a good place to have a break.
Okay, awesome. Awesome. I think you guys are ready for a break, and it's well deserved if you've been listening well and if you've been listening sharply, because Tracy is revising all the stuff that will be in your exams. So make sure that if your pen has run out because you've been writing so much, refill it or get a new one during the break, and we'll see you after the break. Bye. Welcome back, Mindsetters, from that very, very quick and easy break. I hope you guys are ready for another session of intense listening and revision. And remember that all your questions are welcome. Everything that you have to revise, anything that you didn't understand this year, Tracy is here to answer it. And also remember that there is the Casio calculator and the labeler that we'll be giving away to the grade 10 that is on the board today. So make sure that you are participating and interacting with us on the Facebook page, and we'll choose our winner at the end of the show. Over to you, Tracy.
Thank you, Katlego. Oh man, sorry, I got it at the end. I apologize.
It's a bit of a tongue twister there.
Oh man. Okay. You just gave me an interesting question during the break. Don't you want me to read it for me?
Okay,
and then
sure.
I'll see if I can answer it, because it's part of what we're doing here.
Okay, sure. Raymond asked, why didn't you divide the box of elements into metal, metalloid, and non-metal?
Okay, Raymond, I could have. I think I know what he's asking me, is why didn't I divide it up first and then do all the stuff? I could have done that if it makes it easier. That it's just, I didn't think of doing that. But you're welcome to do that if it makes it easier for you to sort out when it comes to properties. But make sure, Raymond, this is very important, that you don't do that on your answer sheet. Okay, because when it comes to your answer sheet, or if you do, make sure you cross it out so your teacher doesn't mark it. Because, and it's not, it's grade 10 level, we give you a little bit of leeway, but there won't be much. But in matric, when you write your exams, when you answer your question, we mark whatever you write first. And I've seen this where a child's written stuff and it's very obvious that it's their thinking, but they don't cross it out, but it's wrong. And then underneath, so they sort of do stuff, and then it almost looks like they've tried the question again, and they do the proper one underneath, but we have to mark what's written first. So, Raymond, be careful with that. It's not a bad idea to divide it up into the 3 groups, okay? Or even take your periodic table out and mark it on your periodic table where they sit. They might make it easier as well. It really is up to you. It depends on how confident you are and whether you really know what the properties are and that sort of thing. So that's more an exam technique than answering the actual question. Okay, so just be careful that you don't make that list and then forget to cross it out, because that breaks my heart. It makes me want to cry when I see that. Okay, so now we get to the fun part, to the part which I know you guys hate with a passion. So we have a graph that says to us a substance is heated. Okay, so first key word, at a constant rate. So we keep the temperature of the plate constant, or the Bunsen burner, whatever it is we're using. And a graph is drawn showing the temperature change versus time. Be careful, grade 10s. I did not say this was water, okay? Do not describe this as a water heating curve, okay? Because it's not a water heating curve. It's a substance. It could be anything, okay? Another hint that I know it's not water, look at where these phase changes take place. One takes place at about 70 degrees, and the other takes place at 140. No ways is this water. Because remember, your melting point of water is at 0 over here, okay? And your boiling point of water is at 140. So, sorry, it's at 100. So please be careful. When it comes to now describing, this is a complete description type question, okay, because we're really seeing whether you understand it, so I'm hoping you're going to be listening. I'm not going to do too much writing. And when it comes to this type of question, be very careful how you say things. Don't say the water molecules, because I haven't told you it's water. Okay, so let's get into it. What can they ask you? Well, before you even look at the questions, before you even look, we go, okay, we've seen something like this before, and we know that the graph actually has a couple of places that are quite important. This is an important part of the graph, and this is an important part of the graph, because remember with your heating curve, when the graph goes flat, that's when the changing phase is happening. Okay, so over here, it's going to start as a solid. Eventually, it's going to be a gas by the time it finishes. This middle part is where it's a liquid. So, from B to C, we have a phase change happening. This is where it's all starting to become liquid. From D to E, we have another phase change happening, so it's where it's all starting to become a gas. Okay? All right. So, first question. Describe the motion of the particles. Okay, that should have said between point A and B. Sorry. Sure, I should really check this. I apologize. That should say between A and B. That's far too much to do in one point. So, between point A and B here. Here, it is a solid becoming a liquid. So the first thing I need to see when you describe the motion is that because it's a solid, okay, solid particles vibrate on a fixed axis next to each other. They're very close, they're vibrating, but as they're vibrating, the temperature's increasing, which means they're vibrating and that vibration is getting more. So they're gaining kinetic energy. Okay, so between point A and B, we have a gain of kinetic energy within the particles. Then, between B and C, now we're having, because it says what is happening, we're having phase change. So between B and C, this is where the phase change is happening. It's going from a solid to a liquid, okay, because the gas particles are absorbing potential energy. Okay? Then, what is the phase of the substance between C and D? Oh, look at that. We've written it in. Okay? Grade 10's the biggest hint I can give you, the best exam tip I can give you, is look at the graph, think it through in your head first, write on the sort of stuff I've just done, and then look at the questions. Because we've already answered a question without even seeing it. Yes, sometimes you're going to put more information than you need. Sometimes you're going to have stuff on that doesn't come up, and that's okay. But it just gives you that confidence to say, I know what the graph is telling me, I can interpret the graph, and I understand the information, because that's really important. Okay? Then I asked you, explain what is happening between D and E. Well, D and E, we've already said, is another phase change. So it's the same explanation as between B and C. We're gaining potential energy, but now the phase change is from liquid to gas. Okay, so don't go and say, well, it's the same as between B and C. No, it's not. The energy is the same, but there's a phase change. I need you to also get this. How do I know that it's not a kinetic energy change, that it's a potential energy change? That comes from temperature. The definition of temperature in science, okay, it's not how hot something feels. That's how we define it, because in layman's terms, in everyday terms, that makes sense. Temperature is defined as the average kinetic energy of the particles. Now here, the temperature is not increasing or decreasing, which means the average kinetic energy isn't changing. Okay, so if the average kinetic energy isn't changing, but we're still putting in heat, we're still putting in energy, that energy's got to go somewhere, so it becomes potential. Okay, and that potential is what it needs in order to break all the intramolecular bonds, okay, the bonds that keep it as a solid or a liquid or a gas, to break those in order for it to change phase, or to make them stronger, okay, in order for it to go the other way around, go from gas to liquid, etc. Then, describe the motion of the particles between points E and F. That's when it's a gas. Well, here, the particles have a lot of kinetic energy. They're moving really quickly. They are very far apart from each other, and their movement is completely random. Completely random. Not fixed at all. And now we get to the fun part, because it says to you, what is the melting point, and what is the boiling point of the substance? Now, that we read off the graph. Don't try and work it out. This would be worth 1 mark, maybe 2 marks, depending on how nice or not nice your teacher's feeling at the time. And we've already marked it on the graph, so that's about 70 degrees, and that's 140. Guys, if you're given a graph like this, this is an accurate graph, okay? It is drawn to scale. So, and it might be difficult to see on the screen, but actually all of these points are exactly the same distance apart. All of these points are the same distance apart. If you are given a graph that is not drawn to scale, you will not be required to read off a value like the 70 degrees, okay? If you ask to take values off that graph, we will have to write in the values and show you exactly where they are. But a graph like this will be drawn accurately to scale. So don't go, well, you know, maybe it's 69.5. No, it's halfway. Trust me on this one. Okay, so melting point is 70 degrees Celsius. Do not forget the unit. And boiling point is 140 degrees Celsius. We could ask you all sorts of questions from this. So I could ask you, for example, if I really wanted to extend it, I could say, okay, so what would the phase of the substance be at room temperature, which is about 25 degrees, though in winter that's more like 12, depending on where you live, okay? It's definitely felt like that in Joburg the last few days, but at 25 degrees, it would be a solid. It only melts at 70. It only becomes a liquid at 70 degrees. Okay, so be careful there. I could ask, well, actually no, I don't think there's too much else we could ask on this. But did I ever, and you got to have understood this, I never once said the word water particles. I don't know what substance this is. Could be anything, it's random. Okay, it's there because we're just trying to see whether you understand what the graph does. Okay, good. Oh, now we get to the point which I know you all love, or not, as the case may be, F-bar diagrams. Okay, F-bar diagrams are so useful, grade 10s. And actually, I'm quite sad that you don't do them after grade 10, because they really help you with an understanding of electron structure. Okay, now, first thing I'm going to do is the calcium atom. And I know you're not going to be able to see this, but you would take out your periodic table, and you would go, well, calcium is actually in group 2, and it's in period 3. It's over here. Okay, so it's right there on my periodic table. Make sure you can find it. Calcium being Ca. Now, looking on my periodic table, I go, okay, calcium is element number 20. That means calcium has, let's do this, 20 electrons, okay? So, that means I need to use, and it's the biggest element, it's the biggest of my diagram you can be required to draw. That means I'm going to need to use 4 energy levels, okay? So, we got 1, and remember, we're going to draw these together. I might have to just take my calcium out in a second, because we're going to run out of space. Let's do this. Okay. The one I wanted. Okay. And you would draw this nice and neatly because you love your teachers and you want to make it easy for them to draw. Okay, so this is calcium. Calcium has 20 electrons. We have the first s orbital, the second s orbital, the second p orbitals, 3s, 3p, and 4s, and we go, okay. Each of these blocks can hold 2 electrons because they each represent an orbital. Each orbital can hold 2 electrons, which have opposite spin. If we don't give them opposite spin, they cannot share the same space. You've done a little bit of magnetism already in your electrostatics. And remember that in when your electrons spin on their axis, that creates their little magnetic field around them. The only way two substances or objects of the same charge can share that space, remember they're both negative, they don't want to be together, the opposite, like charges repel. You learned that in electrostatics as well. But if they spin in on the axis and they spin in opposite directions, their magnetic fields are in opposite directions, so they can actually spend time together, which is a good thing, okay? So, this is how we fill up our F-bar diagram. We go one energy level at a time, so we go 1, 2 electrons, half up, half down, there are half arrows. Then we fill the 2s orbitals, got slightly less energy, so that's 3 and 4. And remember, when you're filling up the p orbital, it's like when you get on a bus and it's full of strangers. You're going to want to go sit in the seat on your own if you can help it. You only sit next to someone if you really have to, because there's no more space. Electrons are the same. Okay, so we go, that's 5, 6, oops, sorry, wrong way. 1, 4, 5, 6, 7, 8, 9. Ooh, that's only 10. Yeah, it's got a lot of electrons. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's happy. Understand, please, though, grade 10s, that is not a full energy level. 4s is not full. Okay, the orbital 4s is full, but the fourth energy level is not full. We stop there at grade 10 level. In fact, that's where we stop at school level, because from here we have to add d and f orbitals, which we don't do because it just gets really complicated. So we're going to leave those. Okay. Oh, wrong one. Fluorine ion. Ion. Yeah, very important. What does that mean? The fluorines are the lost or gained electrons. Here I'm testing two things. One, can you draw an F-bar diagram? 2, do you know what type of ion fluorine becomes? Now, on your periodic table, fluorine is element number 9. It is a halogen, okay? It wants to gain one more electron in order to become like neon. That's what it wants, okay? Because then it has a full energy level, and fluorine is F minus. It's only got 9. We're going to add 1 in. That means it's going to have 10. So I actually only need these first 2 levels. So I need 1s, 2s, 2p, and I'm drawing the F minus. And let's make them green now. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're actually just testing whether you can count grade 10s. All right, so fluorine ion, nicely done. What are we testing up our diagrams? Are the arrows up and down? Do you have them in 2 directions? Are they labeled? Did you tell me which orbitals you're using? Have you got the correct number of orbitals, correct number of arrows, and did you tell me which element it is, or ion, as the case may be? But we can write this in another way, which actually makes it a little bit easier, because, yeah, you're grade 10, we understand. We also get to that point where it's like, I don't want to draw boxes anymore. It's hard work. So, we can do it as electron distribution. Some of you are going to have learned this as SP notation. Okay? Or SP electron configuration. There's lots of words for it. It's the same thing. Here, instead of drawing the F-bar diagrams, we write it in a notation that makes sense. Now, the first one I wanted was neon, and neon's element number 10. Okay, it's the second one on in your noble gas structure. So 1s2. So instead of drawing 2 arrows, I say, well, there's 2 electrons in the first orbital, and there'll be 2 electrons in 2s2. So that's 4. I need 10 in total, and the p can take 6. So there's my sp notation. Okay, so instead of drawing the orbitals, I write in the number of electrons there are. Okay? Potassium ion, now we go look on our periodic table. Potassium is in group 1. Period 4, it's element number 19. In order for it to become a ion, it's going to give away its electron as a metal. Okay, and it's in group 1. So for it to have its valency of 1, it's going to give away 1 electron. If it gives away 1 electron, that means it's going to have 18 electrons in its outer shell. So we go 1s2. I already know that these 2 give up to here gives me 10. So I need 8 more. So 3s2 and 3p6. Okay? Wow. Lots of stuff. I think we need a break.
I think we do.
We do.
So many numbers, so little time.
I know.
Guys, get ready. I hope you're ready for your quick break, just so that you can get a little bit of a stretch going and then be back. See you after the break. Welcome back, Mindsetters. I'm loving the interaction between you guys, answering each other's questions and helping each other, and also asking questions of what you're not understanding. It's really great for Tracy as well, just to see how far you guys are so that she can help you, because that's exactly what she's here for. So it's awesome that you guys are asking good questions and concise questions. We're enjoying this. Hey, Tracy?
We are actually, and in fact, I think you've got some really nice ones for me at the moment, which I'm really liking. So let's hop on into those, and then I'll do some balancing.
Awesome. So someone asked, Lucinda asked, why do we use half arrows for that aufbau diagram?
Okay, Lucinda, that is the correct way to do it. It's the convention. So if we go back to those diagrams quickly, your teacher might have taught you, might have taught you to do it like this and told you to draw, maybe I should pick a pen color, hey? Draw full arrows. That isn't necessarily incorrect, but if you go right back to where aufbau diagrams were first invented, put together, it's the half arrows, and it's just because of the way they spin, and it's to put them in the same space. Okay, a lot of textbooks, because they're actually horrible to draw, do full arrows. Okay, now you need to go with what your teacher taught you. Sorry, it's been a long hour. Hey? Taught you. For example, at my school, so for all my grade 10s that are watching, I want half arrows because that is the correct way. But if at your school your teacher has taught you to do full arrows, that's fine. They're not going to mark you incorrect on it, but half arrows are actually more correct because it's the convention. It's just the way we do it. Okay. Cool. Yeah.
Cool. And the next question by Alicia is, which is the independent and dependent variable?
Alicia.
Yes,
Alicia. I'm so glad, because we never actually spend a lot of time on how to answer those questions. In your exam, you are almost always going to get one of these experiment type questions, okay? So those experiment type questions, they're going to ask you what is independent, what is dependent. Now, this is the easiest way to remember it. Independent variable is what we control, okay? So like time, okay? We never really measure time. So time is something we control. So we'll have an experiment going for 10 seconds, then we'll measure something at 20 seconds, then 30 seconds, then 40 seconds, for example. When you did the heating curve of water, time was your independent variable. Okay, so we go back to this one, to this here. Time is my independent variable. Your dependent variable depends on what you're controlling. Okay, so here, temperature is my dependent variable. It's what we're measuring. If you've done the physics prac that you were supposed to do, which is the electricity one with circuits in parallel and series, okay, the independent variable is the setting up of the circuit, either in parallel or in series. The dependent variables were the voltage and the current in those sections where you measured them, because those are things you measured. So dependent is what you measure, independent is what you control, and when you draw graphs of those values, independent always goes on the x-axis. Always, always, always. Independent, what you control, dependent, what you measure. I think that's the easiest way to remember it. Yeah.
That is.
Okay?
Thank you.
Next one?
The next one is from Raymond. He asked, is it kinetic energy or heat energy?
Raymond, I like this question. This actually shows a real, and I'm not saying you've got a misconception, it must be the way it's being described to you, but heat energy and kinetic energy are essentially the same thing, but we can't call them the same thing. Okay? Kinetic energy is defined as heat is defined as the average kinetic energy of the molecules. So we experience it as heat because it's the only way we can macroscopically describe it. Okay, so temperature is just another unit essentially for kinetic energy. So be careful with graphs like this. You can't tell me that the heat energy is increasing because it's not. The kinetic energy of the molecules is increasing, which then results in us experiencing a greater heat. Okay, so we can feel that the kinetic energy in the terms of heat. So don't get the two, you can't interchange them, okay? They're very closely related, but they're not really the same thing.
Okay.
Okay,
Yeah.
anyone else on the page? No, not yet?
Not at all.
Okay, brilliant. So, guys, we have, I think, about 6 minutes or something. I'm not sure. But we're going to get there. Guys, balancing equations. This is one of those things where it's got to, you should have done it in grade 9. I have spent some time on it. And it's one of those things, grade 10s, where, oh, please, 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 I'm begging you, learn how to do it. Because if you can't balance equations, grade 11 and 12 chemistry is going to be really difficult. So, and there's lots of ways you can do it. Your teacher's only interested in the final product, by the way. They don't care how you get there. So, aluminium plus oxygen gives me aluminium oxide. So I say to you, write balanced equations for the following. So you would have to rewrite it off your question paper. And you go, okay, now I showed you guys to do it this way. And we said, let's do a list. Okay, we're going to do left and right. There's only 2 things here, aluminium and oxygen. And on the left-hand side and right-hand side, or products and reactants, however you want to describe it, we go on the left-hand side here, I have 1 aluminium, 2 oxygen, 2 aluminium, 3 oxygen. And remember, good place to start, get rid of the odd number. Okay, so we want to get rid of that 3. Easiest way to do that is say, well, let's multiply that by 2. So what that means is the oxygen changes to 6, that aluminium changes to 4, and now we go, ooh, small problem. Only have 1 on the other side, so let's multiply aluminium by 4. Okay, and now we're going to change 2 to 6, so we're going to multiply by 3. And that is 6. We have a balanced chemical equation. Off we go. You would need to rewrite this on your exam paper so that your teacher can see nice and neatly that you can balance the equation. Okay? Brilliant. So, next one. I'm going to take this out so I've got myself a little bit more room. Okay? And NH3 plus O2 goes to NO2 plus H2O. So here we've got nitrogen, hydrogen, and oxygen. So let me do this. Give myself a little more room. So I've got nitrogen, hydrogen, oxygen. It's the left side, it's the right side. And you see I'm not writing this in the neatest on the planet because I'm not that interested in marking that. So on the left-hand side I have 1 nitrogen, 3 hydrogens, 2 oxygens. On the right-hand side, 1 nitrogen, 2 oxygens, because I've got 1 here and 1 there. Oh, no, sorry, I put the 2 in the wrong place. Let's put it in the right place, shall we? 2 oxygens and 2 hydrogens. Okay, so actually, the issue with this one is the hydrogens, to start off with, because I have 3 on the left-hand side, 2 on the right-hand side. Have to get rid of the odd number. So let's make blue is not going to work. So let's multiply this one by 2. So because I have to multiply the NH3 by 2, remember, I can't change the little numbers because then I'm changing the compound altogether. So that changes this to a 2, and that becomes 6. And we go, doesn't look like we're getting anywhere very fast, but it's okay. This is exactly how you do in your exam. So now we go, okay, let's change this to a 2, okay? Because then I have 2 nitrogens. It's not changed my oxygens, though, to 3. Now life's not getting fun. Okay, so we go, all right, we need to change the oxygens. I can't change the top one to an odd number. That's not going to work for me. So let's put a 3 in front of the H2O, and that changes hydrogen to 6, because it's 3 times 2, and now I have 2 oxygens plus, I'm going to have to make some space here. That actually now changes to 5. Sure, we're not doing very well here, are we? That's okay. Alrighty, so that didn't work. So now we look at this and we go, okay, I've got 5 and I've got 2. The nitrogens are all fine, okay? It's the oxygens that are the issue. So we go, okay, let's take the 5 and the 2 and change those to 10, okay? So the way I would do this is I need to make this 5. Cool, we've got that. That's not a problem. So that changes to 10. And I need to multiply all of these by 2. So watch what I'm going to do. I'm going to take that 2 out and make it 4. Okay, now watch what I'm doing. Take that out and make it 6. So now my nitrogen changes to 4. Oh, this is even more messy. So let's do this, because now I want you to see what's happened. Okay. There we go. So the nitrogen is now 4 on the right hand side. Okay. Hydrogen is now 12. Okay. On this side I've got essentially 1 and 3. If I ignore, because I'm changing that number, I can make this 4 and 12 by multiplying by 4. Because that makes 4N, 3 hydrogen. So if we want to write this out nice and neatly, 4NH3 plus 5O2 goes to 4NO plus 6H2O. This one was difficult, grade 10s. Okay, I'm not going to make any bones about it. And this is exactly how you got to do it. Please don't give up. Now, we've run out of time, unfortunately, darn, because this particular one, this one, is very difficult. So what I'm going to do is I'm going to give you, this is the hint, okay? And I would like to see who of you guys can actually do this. So we're going to put it on, here it is, and I think you guys need to write the balanced equation for me on Facebook.
Yeah.
What do you think?
I think so too.
And I think,
that's
do you
a
think
challenge.
we can make that as one of the prizes maybe?
Yeah, sure.
First person on Facebook to send through the correctly balanced, which I'm going to give to Katlego before I go, so you'll have it.
Yeah.
Okay, the first person to send through the balanced equation for this, okay, because this is a toughie, this is mean, okay, and I'm going to put it out there, will either get the calculator or the labeler.
Labeler, I think that's
the
a good
labeler.
idea.
Okay, so this is your challenge. If you can balance this, you have got balancing equations licked. Okay, that's
Awesome.
my challenge, and I think that's where we're going to have to leave it.
Sure, thank you, Tracy. Thank
You're
you very
welcome.
much. Thank you, Mindsetters. You guys heard that. You guys have a challenge for tonight. Make sure that you get it done by tonight, because the prize will be the first person to get it. I hope you guys had a fantastic show and have an even better practicing and revising evening. See you next week. Bye.